Today we are going to discuss the problem, given an array, return the first k elements by value. Return empty array if array is null or k is greater than array.length. So this is an example of what we want to achieve here. I have this array here and my k is equal to 3. I want my result to be the first 3 elements by value. Remember, the result does not have to be in ascending order. It should just contain the first k elements by value. So, for example, this is also a valid result. Now, the approach here is going to be different than just sorting the array, because one way to do this is to sort the array and then return the first few elements. However, we could instead use what quicksort does is partition the array and continue partitioning it till we have the exact number of elements on the left side. In the sense, on the left side you have k number of elements. One note before we jump in. This is not an exercise in object-oriented design. Now that that's out of the way, let's jump in. So let's first begin by adding the using clause for link, since we will be using link. And now let's start by defining our method signature. So our method signature is going to be public return an array. Let's call this run, since our class name is already first k elements from an array. And let's take a look at what the parameters need to be, which is the array input and int k. First, let's define the error conditions. So if k is less than equal to 0, we want return an empty array. Second is, let's make sure that there are at least k elements in the array. Less than k. Then return new 0. Oops, there's a slight error here. Okay. Now, what we want to do is start with the whole array and then start partitioning it. So we'll need two variables to start, which is initialized to 0, and n, which is initialized to array.length -1, which is the last index of an array. Now in here, we want to keep doing this until start is less than equal to end. Now let's start writing the partitioning function. So let's first define what we want to do, which is partition. And then we'll pass in the array, we'll pass in the start, pass in the end. Okay. And let's declare this as a private method, partition. Now, what we want to do here is use a swap index to partition the array. So our swap index will start at the value of start, and for rest of the array we want to iterate over the array, and we want to partition it based on some pivot value. In this case, our pivot value is always going to be the end index. So what that means is that if the value at I is less than value at our pivot, then let's put this in because we want to move our swap index to the next location. Oops. And we want to swap the two values. We can use this new tuple method to do it. So let's say array swap. There you go. Now we can add a little bit of optimization here. What we can say is don't do this, or do this only when swap index is not equal to I. Let's get this formatted correctly. And lastly, we want to swap out the pivot value with the last swap index. Again, we are adding a little bit of optimization by checking if swap index is not equal to end. And finally, we'll return the swap index. Now, where are we? So at this point, we've partitioned the array into two sides. And now what we want to do is check if pi plus 1, because that's if index is returned as 1, then the number of elements that array constitutes, including that index, is pi plus 1. So that's why we are going to check this against k. And if the partition index is actually at partition index plus 1 is equal to k, then we can break out if partition plus 1 is less than k, then we know that we have to do more partitioning to the right. So that's why our start value is now become, and else our partition includes too many elements, so we want to reduce the size, so we'll go to the left. When this finally finishes, at some point pi plus 1 will be equal to k, and once it breaks down, all we have to do is return the first k elements to array, because we wanted to return an array. So this is it. So this is going to return us the first k elements by value. Now to test this, I've already written this class called arrays test, which is a test class, and I have a number of tests defined. So I have my array defined here. I have the k value for the first test, I'm going to go create an instance of this class and start running the test. So my first test, as I said before, is k equal to 3. The second test is k equal to 5. And the third test is k equal to 1. One thing to note here is sorting is required, but not because we want the results sorted, but just to help us assert. So now let's go and run these selected tests. It's taking some time to run, but it should be up soon. Okay.
Okay, now there it is. It has started running. It's discovering the test. The run has started. And there, the run finished and all our tests were successful. Now let's go to the algorithm class for just 1 minute and cover something else. In this example, we chose the end index as the pivot in every case. You could potentially change that to randomize this between the start and end index, both included, and that is one variation you could use. So that's it. Thanks for watching.